Hello, so let's resume with summer 21 QP13. So question number 12 is that what is a couple? A pair of forces acting in the same direction. Couple acts in opposite directions. So this is wrong. A pair of forces that are equal and opposite but acting along different lines. This seems to be the correct option. Let's see the others. A pair of forces that produces no resultant force. That's wrong. A pair of unequal forces. That's also wrong. So B is the appropriate answer. Question number 13 says that four coplanar forces are acting on a rigid rod as shown. Which force produces the greatest moment about point P? Let's find moment about each point A, B, C, and D. At A it's 10 Newton meter, 10 into 1. At B it's 6 sine 30 into 2, so that's 6 into half multiplied by 2, that's 6 Newton meter. At C it's 2 multiplied by the distance 3, so it's 6 Newton meter. And at D it's 4 into sine theta into 4, the distance, which is 8 Newton meters. So A is the appropriate answer. So question number 14 says a book of weight W has a rectangular shape and is of uniform thickness. The book is held in a vertical plane so that the longer side of the book are vertical as shown. Which expression gives the approximate torque exerted by the hand on the book? So basically, the torque exerted by the book on the hand is from the center of gravity of the book. This is a uniform shape rectangle, so the center of gravity would be the midpoint of diagonals. So this torque by the book on the hand would be in a anti-clockwise moment, and that would be W multiplied by the distance along the hand from hand to the center of gravity, that would be A by 2. So let's write an expression. So the torque exerted by the book on hand is in anti-clockwise direction, that is WA over 2, whereas the torque exerted by the hand on the book, which is being asked, is in the clockwise moment. So that would be WA by 2. So WA by 2 clockwise, A is the appropriate answer. Question number 15 says that the derivation of the pressure equation, pressure is rho gh, uses a number of relationships between quantities. Which relationship is not used in the derivation of the equation? Density is equals to mass over volume is used. Potential energy is mass acceleration into height is not used. Pressure is force over area is being used, and weight is equals to mass into acceleration is being used. So the correct answer is B. So the question number 16 is a spring is initially neither compressed or extended. A force can be applied for the spring so that it is either compressed or to a shorter length or extended to a longer length. What is the change in elastic potential energy in the spring when it is extended and when it is compressed? So basically, elastic potential energy can be written as half Fe, which can further be written as F is equals to K after F is equals to K substitution Ke square. So either the change in length is positive 2 or the change in length is negative 2, compressed or it is extended. The answer would always be positive because the value of extension is being squared. So when the spring is extended, the change in elastic potential energy would increase, and when the spring is compressed, the elastic potential energy would also increase. So D is the appropriate answer. So question number 17 says a sample of gas is sealed in a cylinder by a piston. The frictionless piston is free to move so that the pressure of the gas remains constant at 1.8 into 10 raised by 5 pascals. The gas initially occupies a volume 2.4 into 10 raised to the power negative 4. The gas now does 14.4 joules of work. So that means that the gas is expanding. What is the volume of the gas after doing this work? what we can do, as the gas is expanding, we can apply the formula work done equals to pressure into change in volume. Work done equals to pressure after expanding minus V1 initially. Let's plug in the values. So V2 from here becomes 3.2 into 10 raised to the power negative 4. So C is the appropriate answer. So question number 18 says a car of mass 500 kg is at rest at point X on a slope as shown. The car's brakes are applied and the car rolls down the slope with its engine switched off. At the point Y, the car has moved through a vertical height of 30 meters and has a speed of 11 meters per second. What is the energy dissipated by the frictional forces when the car moves from X to Y? So we just need to do is find the potential energy at point X, and then we need to find the kinetic energy at point Y. The difference between the energy would be the frictional energy. Let's write down the potential energy equation. Let's plug in the values. So let's solve it up. We will get 147,150. Set up equation for kinetic energy. After plugging in the values, we will get 30250. So the difference between the two is the frictional energy, that is 1.2 into 10 raised to the power 5. So B is our appropriate answer. The next question says that question number 19, which expression cannot be used to calculate power? So power is energy per unit time, force into distance over time, and it is also force into velocity. So let's see, force into displacement into time, that's correct. Force into velocity, that's correct. Work done per unit time, energy over time, that's correct. Work done into velocity, that's not correct. So the appropriate answer is D. Question number 20 says the stress in a material is given by the equation stress is force over area. The strain in the same material is given by the equation strain is x over L. Which expression gives the Young modulus of the material? So Young modulus can be written as, let's keep strain as it is and plug in the values for stress. Let's rearrange it. So from here, D is the appropriate answer. So question number 21 says that what is an example of plastic deformation? A rubber ball is momentarily compressed every time it hits the ground. No. A spoon stirring some coffee in a ceramic mug hits its surface and makes a clinking sound. No. A toolbox is left on a horizontal plank. When the toolbox is removed, the plank is no longer straight. So that means that there has been a permanent extension. So whenever a permanent extension is being seen, so that is an example of plastic deformation. C seems to be the appropriate answer. The D is the spring is some bathroom weighing scale is compressed by a person standing on the scale. No, it will return. So that's not the correct answer. C is the appropriate answer. Question number 22 says that a transverse progressive wave of wavelength lambda is set up on a stretched string. The graph shows a variation of the displacement y with distance x at a particular instant of time. The wave was displaced positive y1 at distance x is equal to lambda by 8. What are the next two values of x where the displacement y is again equal to positive y1? Let's draw a line on the graph. Now let's see the instance when y positive y1 displacement is seen. This is the first instant, which is lambda by 2 minus lambda by 8. Now let's see the second instant, and this is the second instant, which is lambda plus lambda by 8. Let's calculate and find the answer. So this makes 3 lambda by 8 and 9 lambda by 8. So B is the appropriate answer. So the next question, number 23, asks us to find the wavelength of the wave. So we can find the wavelength from V is equals to F lambda. We can find the time period from this wave. The time period is 20 milliseconds. From here we can find the frequency. So our frequency is 50 Hz. We can plug in the values for velocity and frequency and find our wavelength. So our answer is 6.6 meters. A is the appropriate answer. Do not forget to subscribe my channel. Thank you for watching the video, and to all new viewers, please subscribe my channel and like my video and share it among your other fellows. Thank you.